Great. Welcome everyone to the CDR and Databricks Lunch and Learn. I will be sharing these links that you see on the screen here in the chat shortly. When you did join this call today, you were prompted to put a passcode, and this will apply for all future sessions. Unless that changes, we will let you know. Let me go ahead and move on to our administrative announcements. This meeting is being recorded, so please stay muted to minimize interruptions. Since this session is short, it will not feature a Q&A section. You are more than welcome to use the Zoom poll at the very end of the call to ask any questions. And of course, all meeting materials will be made available in the CCSQ DNA portal. Just make sure to give us some time to turn those around. With that said, I'm going to go ahead and stop screen sharing and hand it over to our speaker, Tim.
All right. Thank you, Laura. And we are recording. Awesome. So my name is Tim. I'm here on the user services team, and today we are going to talk about the Pandas API in Spark. So welcome to my Lunch and Learn. I am going to begin sharing. You know what? I will also share my notebook for the day in case you'd like to follow along. Of course, you won't be able to use my notebook, but you're free to clone it. There it is. Share this window. Okay, so I'm going to talk about the Pandas API in PySpark. What are we going to talk about? We are going to understand what that is, the Pandas API for PySpark. I know it's a mouthful, and when to use it over its alternatives. We're going to create PySpark Pandas data frames, and we're going to distinguish it from plain old PySpark and plain old Pandas. And we are going to use the common Pandas style operations to process data in PySpark. And we're going to recognize the performance considerations and how to convert between these types. So I have a quick icebreaker. What's going on? How are you feeling about your overall Python experience so far? Where are you in your SAS transition? Are you familiar with Pandas? Are you just coming to Python from SAS and only have experience with PySpark? So feel free to just sound off in the chat. I want to dedicate like a minute or two to this because I just want to kind of gauge where we are. Interesting. Not too much with Pandas, mostly PySpark. Primarily have used Pandas. Familiar, but not used to it. Cool. This training might not be for you. That's okay. Welcome anyway. A little bit of Pandas. Familiar with Pandas. No PySpark yet. Cool. Pandas. Understand the difference and what works with each. Gotcha. Cool. I'm actually pretty surprised to hear how many people are familiar with PySpark, but not Pandas. Because it wasn't that long ago that when you started to learn Python and you were a data person, you just went right to Pandas. It was like, learn Python, then Pandas, call it a day. But now because of our system, I know many of you are transferring over from SAS. You're going straight from Python to PySpark, which is not very typical, I would say, and is maybe like a sign of the times that big data is really kind of the norm now, and Pandas, as we're going to talk about, can't really handle big data. Very interesting. Cool. All right. So for those of you kind of just learning what Pandas is, what is it? It has absolutely nothing to do with the black and white mammal. It actually is short for panel data system. I don't know. It is a very popular Python library for reading, manipulating, and writing data frames. It is the go-to library for working with single-threaded data in Python. As I mentioned earlier, it also tends to be the first thing new Python users learn when coming to the language. So if you were just doing data analysis on your personal laptop, no Spark server required, most people would reach for Pandas to solve those sorts of problems. But it can't handle large data. It is limited by the RAM you have on a single machine. So if you've ever experienced the woe of trying to open a 10 gigabyte CSV on your laptop, you know what I'm talking about. So instead we use PySpark, a distributed data analysis tool that has practically unlimited capabilities and capacity because we split our calculations across many machines. If your machine is too small, just get more machines, and all of a sudden PySpark can handle it. Pandas users find PySpark syntax cumbersome and unintuitive. That was me for a long time. I was primarily a Pandas user, and PySpark felt a little unnatural. So today's talk is about the Pandas API in PySpark, a Spark-safe way to use Pandas all within our distributed ecosystem. And I've got sort of like a bottom line upfront kind of table going on here. All right. Let me X out of my email because every time you clone my notebook, I think I'm getting an email. So I'm not sure how to mute it. All right. Okay, so what's the bottom line up front here? So Pandas, the pros are it's easy to use. It's got a really familiar syntax. I mean, if you are familiar with it. But the cons is you just can't use it for big data. PySpark, on the other hand, is ideal. It is the go-to technology for working with big data, but the syntax is kind of weird, especially if you're not used to it. What we're going to talk about is the Pandas API in PySpark, which is really the best of both worlds. It works for big data, and the syntax should be very familiar if you are used to Pandas. One quick weird note is that the Pandas API for PySpark and PySpark are using slightly different backend technologies. In particular, the traditional PySpark is using a SQL-ish backend. So you might have found that PySpark variable names were case insensitive. The Pandas API doesn't have that SQL-related backend. So we have to go back to being really case sensitive here. Uppercase and lowercase letters are different again. All right, so how do we get started? How do we create one? So first you have to import the API. So import PySpark.pandas as PS. It is traditionally abbreviated PS. Pandas without PySpark is traditionally PD. So just a little bit different. One more thing here is I'm going to set a configuration setting. When you try to do certain things, when you read in certain kinds of data sets, you get some warnings, not errors. I'm just shutting them off. This is optional, but it's going to save like a little bit of a paragraph of output that I just don't feel like looking at. Run this. And I'm going to show you two ways to create Pandas PySpark data frames. Sorry, I know it's a mouthful, but there really is no shorter way to say it because I don't want to say like just Pandas. So the first way is to just use PySpark and then convert it. So oftentimes we are reading our data from SQL. So maybe I'll say select star from whatever, and I just picked some arbitrary data set in our community schema. And then you just say .pandas API, and then I saved it as something else. So I want to emphasize these variable names because we're going to use them throughout this notebook. The traditional Spark data frame is just df PySpark. And then when I convert it to Pandas, it's just dfps for PySpark or for Pandas. And if you don't believe me, we can finally call .head. So if you are like me and you just compulsively call dataframe.head and you're annoyed that PySpark doesn't have a .head, here's some evidence that there is indeed a .head that you can call on these Pandas data frames. And I did have a little bit of issue connecting to my cluster this morning. I don't know if anybody else is having this issue, but this should not take 20 seconds like it is right now. Should only take maybe like a split second. There it goes, yeah. Brittany asks a good question. It's the next thing I'm going to talk about. What about importing files from the S3 location? So option 2 is to read directly into pandas from a file. So I didn't prepare a file for us today because I didn't want us to get like overblown with like mounting and then reading from the S3 bucket, but you would use the exact same process you would use in PySpark. You would mount the S3 bucket, you would read into the Pandas API, and then you would unmount it later, where it's actually even easier. You just say ps.read_csv or ps.read_parquet. And I think that's a little bit easier than what PySpark gives us because you have to set all those options. And if you would like, you can even use the autocomplete here to see what else you can do. So it's ps.read_, and you can see all of the other things, right? Delta tables, right? That's a big deal. We're kind of trying to push a lot of users to be using parquets and deltas because those are more distributed, friendly data formats. Those are still accessible from this API. CSV, of course, Excel, HTML, JSON, and then all the SQL options. Sorry, Brittany, I don't know if I'm going to be able to debug that live, but watching for now is probably okay. You can definitely get the notebook a little bit later. Or Dan has updated the permissions. Thanks, Dan. All right. I just called it .head. One thing I want to show you that I'm also kind of annoyed that PySpark doesn't have, but now Pandas does, is .shape, right? Just tell me the dimensions of my data frame. So .shape is going to give us a tuple of rows and columns. So my data frame here is 428 rows and 15 columns. And you get the same output that you would in traditional pandas, but here we see a pretty glaring difference between classic pandas and the Pandas API on PySpark, if you have used pandas in the past, that is to say. When you use traditional pandas, calling .shape is just a attribute of the table, right? It has these many rows and it has these many columns. You call it dataframe.shape and it takes a split second. But here we see a very key difference. A Spark job ran. There were actual Spark processes that ran in the background when you called .shape. This is to show you that just because it looks and feels like pandas, it is still PySpark on the back end. To compute the number of rows of a data frame, that is a Spark action. You're calling a .count. .count gets you the number of rows of a table. It's not for free. If your data frame is super big, this might take a good couple seconds. So it looks and feels like pandas, but really it is PySpark on the back end. And to maybe emphasize really that these are different things, the type function in Python, if you've never used it, just asks what kind of variable this is. So df PySpark is a PySpark SQL data frame, or just a PySpark data frame for short. And the dfps variable we've been working with is PySpark pandas frame data frame. So a little bit more familiar, but they are different objects here and therefore have different methods associated with them. Okay, now I want to show you what's the same. So I'm going to go through some of the very common, data frame manipulation actions in both PySpark and Pandas and kind of show you how they're the same and how they're different. So I'm of course going to import PySpark SQL functions as F. This just shows up all the time when you use PySpark. So selecting, maybe we have done some select work in PySpark. You just select the 3 columns you want and you display it. And the display function, I'm sure you've used this many times. The display function gives you a little GUI here where you can like scroll through your data, and that's super useful. But as we've seen, we have .head, and if you're familiar with this bracket notation in Pandas, it is the same, of course. So what we're doing is we're not actually using a special double bracket notation. What we're doing is we're indexing the data frame by a list. So the inner brackets are a list of 3 strings, and then the outer brackets are how you're indexing this column. The .head method shows you, by default, the first 5 rows. So like the head of the data frame from here to here. It's just a very quick way to show you a quick glimpse of the data set. If you put a different number in the parentheses, it would show you a different number of rows. All right, sorting. PySpark really likes to take after SQL syntax. So to sort in PySpark, you use order by because it's also order by in SQL. So df PySpark order by weight, and here I'm free to use a capital or lowercase w because PySpark is case insensitive. So now if we display and I scroll over, it's one of the last columns. We are sorted by weight here. These are cars, by the way. I didn't say it out loud, but this is a data frame of different cars. Sorting in pandas is df sort values, and I have to use the capital W here because, again, we're case sensitive again. And the reason I'm commonly calling dot head is because if I don't call dot head, it's going to try to show me every row of this data frame, and that's just going to like take up the whole screen. So I just call dot head just so that we're not kind of flooded with information and we just get the first 5 rows. So again, the same output has happened. The weight, we're sorted by weight here. Filtering, this is where things get a little weird. So to filter in PySpark, we do dataframe.filter, and then inside the filter, you put the condition. So I have to call f.call so that PySpark knows I'm referring to this column. So f.call of MPG highway is greater than 50. And I think this leaves us with 3 rows. Yeah, so these are all of the cars with a fuel economy on the highway greater than 50. Now, if you're not used to pandas, this actually looks more confusing, even though it's a little bit shorter. But if you're used to pandas, you kind of hopefully know what's going on here. To filter a data frame in pandas, you say data frame bracket, and I often encourage people to read the brackets as such that. So data frame such that the highway is, or the MPG highway is greater than 50, where of course you have to say dfps dot MPG highway to emphasize that it's coming from the same place. So again, I think that this is maybe one of the times where the pandas syntax is actually a little bit less intuitive, but if you've been using pandas for years and years like I have, this does kind of feel like second nature, even though I recognize it's a little bit funky. We get the same result. Next, real quick, creating new columns and dropping columns. So I'm going to create a list here just for ease of use in the next couple cells. I'm just going to refer to 4 columns. So make, model, weight, and a new column I'm going to make, which is the weight in tons. So to create a new column in PySpark, you have to use this kind of weird with column method. So df PySpark.with column, and then you say the name of the new column you're creating and the calculation that makes it. So I'm taking the weight and dividing it by 2000. And I'm selecting these new columns that I've just created, just so that our data frame is a little bit thin. Right? And that's how I create a new column. Notice the reassignment here. Python, PySpark being based on Scala means that no actions will change the data frame unless you reassign it. That is a feature of Spark. It's on purpose. So in order to actually save that new column, I have to assign it to a new table. So df PySpark.with column.select is going to be equal to df PySpark new, and then I can show you df PySpark new. Where with pandas, it doesn't work that way. To create a new column, I think the syntax is a little bit easier. You just assign it, right? So df bracket, the name of the new column, is equal to the calculation that makes it. So df weight in tons is equal to the weight divided by 2000. And that operation permanently adds it to the same table, and we can look at it. So that's adding a column. Let's drop it. Let's say now that I have the weight in tons, I don't need like the original weight. So I could drop it. So df PySpark new dot drop weight, and then I'll just show the first 5 rows here, kind of like head in PySpark. So again, this isn't permanent. I didn't actually permanently drop this column. So if I do df PySpark new.show like this, it's actually still there. In order to permanently drop a column, I would have to reassign it like I did a couple cells up. The reason I'm emphasizing this is because Pandas has very deliberate syntax for making these changes permanent that actually does not translate into PySpark, or that does not translate into Spark in general. So df_ps also has a dot drop, but when I try to show you this data frame again, weight is still there. This change is not permanent. If you're used to regular old pandas, you'd be like, okay, I'll just say in place. And you would just say in place equals true. And when you ran a command that said in place equals true, that would make the change permanent. It would change the data frame in place without reassigning it. In place methods don't exist in this Pandas API for PySpark. That is by design, because under the hood, everything has to run through Spark, which has to run through Scala. And this is just not a programming practice that this language is okay with. So no in-place methods. I think if I ran it, I'd get an error. Yeah. Unexpected keyword argument in place. So in order to make the change permanent, I would have to say dfps equals dfps.drop, which is also kind of a bad practice. You should give it a new name, but if you really wanted to make it permanent, you could do something like this. Hopefully this isn't getting boring. I have one left, aggregating with group by. I just think that's kind of like the last classic thing that you typically see. So to do this in PySpark, it's dataframe.groupby.ag, and then you get to kind of use SQL-ish syntax to name it. So take the mean of the miles per gallon highway, and then you could alias it with average MPG. And then .order by, I'm just going to order by the number of cylinders so we get it in the same order. There we go. That is the average fuel economy for the cylinder counts of these cars. Notice that there is a missing category here. There were missing values in this table for the number of cylinders on the car. The syntax in Pandas is pretty similar. It's a little bit more versatile, but also it's not really versatile. There's more ways to do the same thing, but I actually don't think this is as good as PySpark. But here is one of the more common things to do. So you say dfps.groupby, I'll group by the cylinders again. I'm going to put an option in here called as index equals false. By default, it would take the thing you're grouping by and make it the row index as opposed to just a new column. And then I'm going to aggregate the same thing here. The syntax is a little bit different. And then again, I'm going to sort by cylinders. One thing that is different on the output here is that I lost the missing category. I believe the default for group by is to drop missing values in your grouping variable. And I know there's got to be an argument in here for it. I don't want to, oh, drop NA, there we go. Yeah, I discovered it live on TV here. Drop NA equals false. I can keep my missing category. It does get sorted to the bottom though. Lacey, that's a good question, because I'm about to round out this talk by talking about exactly that. Okay, why would you use this and why wouldn't you use this? So why would you use this? When you're getting a new user up to speed, right? Lots and lots of people know Pandas. I would say just generally in the world, more people know Pandas than know PySpark. So if you're getting a Pandas user up to speed on PySpark, this is a great transition. Or if you're taking old code that was in Pandas and you need it to work with big data, which is a very common thing. It's very common to write code that works locally and then have it scale as your business grows. So scaling legacy Pandas code to work with big data, fantastic tool. Rapidly exploring and prototyping data analysis code. You might have noticed in the comparisons up above, the Pandas code is typically shorter, right? If you're just typing really quick and you just need to go, get analysis quick and move on, Pandas is really good for that because it's more familiar for a lot of people and it's a little bit faster to type. It's also good for small to medium-ish size data. think under like 100 million rows. I know it's weird to call 100 million medium-sized data, but lots of companies out there are working with data in the billions or higher. So I would say a rule of thumb is 100 million and lower, you're probably still okay with this. In general, you should consider the Pandas API as comfortable, but not as performant as PySpark. You could use it if you're happy to trade off coding speed for execution speed, right? This is just going to be faster to build, especially if you've been using this for years, but it's going to work a little bit slower. So why wouldn't you use this? So there's some drawbacks here. There are some common operations that can unexpectedly force the computation tree to execute. So lazy evaluation, you lose that benefit. If you're unfamiliar with this term lazy evaluation, what PySpark does is it doesn't run your code right away. It builds a computation blueprint. They call it a computation tree. So it says, okay, you told me I'm going to sort the data, then I'm going to group by it, then I'm going to filter it, then I'm going to do this, but I'm not going to do it until you tell me to. That's called lazy evaluation because it doesn't run until the last possible minute. There are some things in the Pandas API that will coerce that lazy evaluation to run ahead of time, and that can actually really slow your program down if that happens at an unexpected time. Some common operations, such as group bys and joins, are just going to be slower because they map to different operations on the back end. I don't know why they can't be the same, but they are just going to be a little bit slower. Similarly, there are some things that you might be pretty used to doing in Pandas that just are not okay to do in a distributed environment. So they're going to run extremely slowly. For example, iter rows. That is an operation for looping through a data frame one row at a time. It's just going to be extremely slow in Pandas. If they even have that method, I'm not even sure. Similarly, .map and .apply. These are not technically they could be distributed, but they just don't get distributed very well in this API. So as a result, UDFs, that is user-defined functions, they're already slow in PySpark. They're going to be even slower in Pandas. And as I mentioned earlier, it's just not as performant on super big data. Sorry, I know I've got 2 minutes left. So the too long didn't read here is the Pandas API in PySpark is a great tool for rapidly iterating code, adapting existing code, or onboarding new users. But the Pandas API in PySpark is a bad tool for production quality code. It's a little bit slower for some common stuff and a lot slower for some complicated stuff. Additionally, there is an additional slowdown for really big data, so just keep that in mind. All right, time. Thank you so much for joining. Again, my name was Tim, and I think you are going to be sent a survey by Laura. Is that right?
Yep, that's right. Thanks, Tim. All right, I'm going to go ahead and launch the survey. It's only 4 minutes. If you had questions that you did not get the chance to ask them in the chat, feel free to put them here in that survey. We will address it, whether that's in future sessions. Feel free to also give us ideas, maybe things that you haven't seen in Code Commons, in Portal, things that you haven't seen presented on. We can take that feedback and also create more content. Of course, let us know how we're doing so we can continue improving. Just so everyone is aware, we will have an office hour session next week at 2 o'clock. Those invites will go out here shortly. You don't have to register. You just have to be subscribed to our mailer list. If you or your coworker are not receiving the invite, feel free to just reach out to me. I'll make sure you are on the list and you are getting the invites for future training sessions. Once you do take the poll, feel free to drop. And as a reminder, if you or your coworker want to go back and rewatch today's recording, it will be posted to Portal. Just make sure to give us a few days to turn those around.
All right. Thanks again, everybody. See you later.